Okay, so which one of these in 3, 4, and 5, 4 and 5 were not functions? Why not? Alejandra?
What was 5? It had like a repeating domain.
Yeah, stuff shows up more than once in the domain, right? So x has 1 more than once and 2 more than once, therefore it can't be a function. What about number 4? What about number 4? That one's also not a function. Why, Diego?
Because it has the domain pointing to like different numbers.
Different ranges, right? And so if we think about the birthday problem that we talked about before, where it said like Diego was born in 1 month, he cannot also be born in another. 8 cannot go with -3 and also -9 and also -4, okay? So that means you need to have no repetitions in your domain. Can you repeat in your range? Yes, you can repeat all you want in the range. Remember that a ton of people can be born in December, all right? A lot of people can be born in December, but you can't have more than one birth month. Okay, so the whole point of that is we're going to be able to start using tables and functions to write equations. So take a look at this table. This is a table and it's written horizontally. Typically we draw it vertically, but this one's written horizontally. So this says, here's our x values. What's our domain of this? 1, 2, 3, 4. What's our range? -2, -1, 0, 1. And I want to find a relationship. If I'm going to write an equation, I need to find a relationship. So I want to find a relationship between this x and this y value. So what are some possible relationships to go from 1 to -2? What could you do with 1 to get to -2? For example, if I had 5 and 4, I could say -1, because I did -1 to go from 5 to 4. So what could I do to go from 1 to -2? What are some possible relationships? -3. So I could do x -3. If I take this x value and subtract 3, that's perfect. Is there anything else you could do to go from 1 to -2? What else could you do to 1 to make it -2, Montreal?
Multiply it by -2.
Good. You could do x times -2, or we would say -2x, right? What about, these are two relationships. Are there any others? Is there any other way you can go from 1 to -2? Braylon? We subtracted 3 right here, yeah. So that's our first way, right? So we had, this was our first way. Here was our second way. Those are the only two that I can think of right now. Do those work for all of them? Does this first one work for all of them? So go to our next pair. If I do 2 minus 3, does that give me -1? Yes. If I do 3 minus 3, does that give me 0?
Yes.
If I do 4 minus 3, does that give me 1? Yes. So does this one work for all of them? Yes. So x minus 3 does. Does multiplying by -2 work for all of them?
No.
No. If I do 2 times -2, what does that give me?
-4.
-4. So that doesn't work. As soon as we get to the second point, this equation doesn't work for that second point. So this is then called the rule of the function. So we would say y equals x minus 3. And that's your equation that comes from that table. So you take your y or your x value, you figure out how you get from x to y, and then that becomes the rule of your function. All right, take a look at this second table. How could I go from this first x to y? How can I go from 4 to 2? Brendan? You could either divide by 2 or what? Subtract 2. If I go down to this second one, which one of those rules works? Divide by 2. So the rule here is divide by 2. So that means my equation would be y equals x divided by 2. And that would be the equation of that function. Because no matter what, it always works. And the whole point of that is then I can add in another point here, 20 and 40. And you can fill in the blank. So what would this one be? 10. And this one would be 20. Good, because the rule will work for everyone. It's called a rule of a function. So that's the rule of that function. All right, so when we're doing these, we use independent and dependent variables. And the independent variable is usually x, the input of a function, and the dependent variable is the output of a function. The dependent variable depends on the independent variable, which is why it's called the dependent variable. What does that mean, dependent? Does that mean dependent? Sometimes we say, like, you guys don't do this because you don't pay taxes yet, but your parents say, like, they claim you as a dependent. So, Guillermo, you are your parents' dependent. What does that mean?
You're dependent on
Yeah, what does it mean to depend on something?
you need
You need them, right? You need them to tell you what to, not to tell you what to do necessarily, because you guys probably don't listen to your parents as well as you should, but you should listen to your parents, right? You need that variable to tell you what to do. You depend on that variable to kind of guide you. So in our independent and dependent variable, the independent variable is the input and the dependent variable is the output. So the independent is the x and the dependent is the y. What does input-output mean? What does input-output mean? George? I didn't hear. I'm listening to you. You put something in and you get something out, right? So think of a vending machine, all right? What do you put into a vending machine? Money. What do you get out of it? Food or soda or whatever that vending machine sells, right? Like Skittles or whatever kind of candy you get, chips, whatever. So the input is the money. The output is the food. Okay. All right, so a function is just a machine where the independent variable is whatever you're putting in and the dependent variable is whatever you're getting out. So take a look at these two examples. Now I want to see if we can find the independent and the dependent variable. So number one says, in the winter, more electricity is used when the temperature goes down and less is used when the temperature rises. So what are my two variables there? What are my two variables? What do you think, Alejandra? The temperature and the electricity. Which one of those do you think is the independent variable and which one of those is the dependent variable? Angel?
I think the temperature is the independent.
Okay. And then what's the dependent? Why is this? Why is that one the independent variable and the dependent variable? Why is the independent variable the temperature?
Because if the temperature goes down, then less electricity is going to be used.
Good. Okay, so how, like when you're sitting at home and all of a sudden you're sitting there and all of a sudden you hear your air conditioner start. Does that happen? Like all of a sudden it kicks on. What makes it kick on?
electricity.
Yes, but why?
Because it needs power.
Okay, it needs power, but does that happen in January?
No, for sure.
Does your air conditioning kick on in January? Maybe in Houston, but probably not. Does it kick on more in January or more in August? Why?
Because it's hotter.
Because it's hotter. So Desiree, as the temperature goes up, your air conditioning says, okay, we need to run more, right? So it uses more electricity. So the independent variable is the temperature because that's what's causing your air conditioner or your heater to run more or less. So the electricity depends on the temperature. All right, number two, the cost of shipping a package is based on its weight. So the cost of shipping a package is based on its weight. So which of those would be the independent variable and which would be the dependent variable? Brendan, what do you think? The weight is the independent variable. All right, and then what's the dependent variable? The cost, yeah, okay. So have you guys ever been to the post office? How many of you guys have been to the post office? All right, and if you bring a little box and you're just shipping somebody like a shirt, all right, and you put that box, they put it down on a scale, and then that tells them how much it's going to cost, right? What happens if you also then are mailing a giant old box of books? What's going to happen when you put the books down on the scale? What happens to the price of that box? It goes way up, right? Because the heavier the box is, the more it costs to mail. So the cost, the price of shipping that package depends on the weight of the package. Okay. All right, so what I want you guys to do now is I want you guys to figure out the rules of these functions. So you've got 3 tables up here, and I want you guys to figure out the equation. It should be y equals something, all right? How do you get from here to here? How do you get from your x to your y? How do you take your input and become your output? Remember, it has to work for all of them. And then down here in 4 and 5, identify the independent and the dependent variable. Okay, go ahead and start. So to write a function, if you don't have a table, sometimes all you're going to have is a word problem. So when you're writing a function, the first thing you want to do is identify the variables that you're talking about. So for this problem right here, this problem in red says a lawyer's fee is $200 per hour for her services. So a lawyer's fee is $200 per hour for her services. So what are my two variables there? The hour. Okay, so we've got the time, which is hours. So what should my variable be for that? H. So H equals hours. Okay. And then what's my other variable? Her fee, the money she makes, right? We're going to call it F for fee. So that's how much money she makes. So what equation could I write then that would give me this function in terms of an equation? What could I write? F equals H something, right? H something. Okay. What kind of math would we have to do here? Multiplication. What am I multiplying H by? 200. Matthew, why am I multiplying H by 200? Because for every hour that this lawyer works, she makes $200. So if she makes $200, that means in 1 hour, what would her fee be? 200. In 2 hours, what would her fee be? 400. In 3 hours? 600. And so on and so forth, right? So which is the independent variable here then? Which is independent? Hours. And then the dependent variable is the amount of money she makes. Remember that independent is typically your X. So your dependent is your Y, and this is usually where your Y would go. Your Y would usually go here, so that makes this your dependent variable. The fee depends on the number of hours she works. If she works 5 hours, she makes more money than if she only works 2 hours. All right? In function notation is just a different way of writing it. You don't necessarily have to write them like this. You just need to know what this means. And we're going to look at a couple function notation problems in a second. But function notation is written like this. F of x equals x plus 6. All right? Instead of writing it as y, they write f of x. F just means the function of x. So don't worry about that right now. Just keep in mind this is called function notation. So right here, we would say f of h equals 200h. And we'll talk about what that looks like when you're evaluating functions in just a second. Okay, so take a look at this problem. The admission fee to a local carnival is $8. Each ride costs $1.50. So the admission fee to a local carnival is $8. Each ride costs $1.50. And I want to figure out how much money I'm spending at the carnival. So how would I write that as a function? How would I write that as an equation? What are my variables here? How many rides you ride? Okay, so R is the number of rides. All right, what else do I have? The $8, which is a constant, right? What does it mean that this is a constant? It's not going to change, right? It's not going to change. Okay. The $1.50, which is the price of the rides. So $1.50 is the price of the ride. Is that a constant? Why? It depends on how many rides you go on, right? You could feasibly go to a carnival and ride 0 rides, but you could go to a carnival and ride 22 rides, right? So you can change the number of rides that you go on. It just depends on how many you choose to do, right? So what's all that going to be? I need to put that all together and I need to write an equation. So what would that equation be? What do you think, Emily? Okay, and that's going to equal what? What would that equal? The total, the amount that you spend. So we'll call that T. We'll say the total that you spend at the carnival is $1.50 times the number of rides plus 8. How come you don't multiply 8 by anything? That's a constant. How many times do you have to pay an admission fee? Just one time. So I'm only going to add it on because I only pay it once. If you go on 0 rides, do you still have to pay to get into the carnival? Yes, you still have to pay $8 to get into the carnival. So just for walking in the door, you have to pay $8. Then if you go on 0 rides, you've only paid $8. What if you went on 2 rides? What would you do to figure that out? 2 times 150 plus 8. Exactly. So you plug in the number of rides for R, and then that gives you the total. Brendan?
Isn't this like the
This is written in the same format as the slope equation. Yeah, so y equals mx plus b. Yep, which means that if you graphed it, what would it look like? Like a line, right? It would look like a line. And in fact, this would be it'd be linear and it'd be a positive. It'd have positive correlation, which we'll talk about a little bit later. Okay.
And the y-intercept will be 8.
Yes, good. The y-intercept will be 8. Why?
Because it's plus 8.
Uh-huh.
Because if you graph it, it'll already be at 8. Right?
Yes, which means if you go to the fair, can you ever spend $0? No, unless you stand outside, sadly, holding on the fence, looking at all the people having fun. All right, then you could spend $0. Okay, so to evaluate a function, so for instance, let's say we have this, f of x equals 5x. Find f of x when x equals 6. So find it when f of x when x equals 6. What would you do to find it when x equals 6? Diego? Plug in 6. So you would say equals 5 times 6, which equals 30. So this is function notation right here. All this means is that you're plugging in 6 every time that you see the variable x. So whenever you see an x, you plug in a 6. So if I have this, f of 7.5 equals 5x, that means I'm plugging in what whenever there's an x? What would I plug in this one? 7.5. So you do 5 times 7.5, which equals 37.5. 37.5. All right? So function notation, I don't want, a lot of times people get freaked out because they see this f parentheses x stuff. Don't let yourself get freaked out. Just know that whenever it says this, all that means is just plug it in. All right? All that means is plug in whatever variable is here that goes into the x spot. That goes into the x spot. All right? If it said this, f of x equals 2x squared plus 3x, and you have f of 2, how many times are you plugging in 2? Twice. Every time you see an x, you plug in the 2. All right, so that's function notation. All that means is it's going to look like this. This is the same as if it just said y equals 5x. All right, these two things are exactly the same. This is just called function notation. So the f doesn't really stand for anything. It just means this is a function of x. Okay, go do these 6.